Okay, let's dive right into this. Welcome to this explainer where we are kicking off a sort of family, magic, and science phase. We aren't just going to sit here and look at dry facts and figures today. No way. We are actually going to build something pretty incredible right before our eyes. We'll take completely everyday items and transform them to really understand the physics and chemistry behind a homemade lava lamp. It's like a giant puzzle coming together. Welcome to a great moment to spend as a family. I absolutely love that quote. Because seriously, science isn't just for sterile white-walled laboratories, right? It's about shared discovery. It's about creating those core memories right there at the kitchen table with us. So, let's get into it and bring some fantastic scientific concepts to life in a way that is, quite honestly, incredibly visually stimulating.
All right, necessary materials: a clear plastic cup or bottle, water, cooking oil, liquid artificial coloring, and effervescent tablets. It's incredibly accessible. In fact, you'll likely have the whole shebang sitting in your pantry right now. Just a few simple household ingredients getting ready to make some spectacular homemade magic.
Step 1, fill the cup 1/4 full with water. Super simple. Then, step 2, add 5 or 6 drops of artificial coloring and mix well. This is where your personality gets to shine. Pick your favorite color, drop it into the water, and give it a really good mix so it's completely tinted. This vibrant, colorful water, that's going to act as the heavy lava in our lamp.
Now for a really fascinating part. Water rests on the bottom, and cooking oil floats on top. When you carefully pour that cooking oil into the cup, filling the remaining space almost up to the brim, you immediately see this physical standoff. The colored water stubbornly just rests on the bottom, while the cooking oil floats completely on top. They absolutely refuse to mix. It's like they're putting up a wall, forming two very distinct layers.
Let it sit until the water and oil separate completely. I know, we just want to get to the action, but here is where we need to exercise just a tiny bit of scientific patience. Take a breath and just watch. You'll see these tiny bubbles of colored water caught up in the oil slowly sinking back down. Trust me on this, the smoother that dividing line is between the colorful water below and the clear yellow oil above, the better your final result is going to be.
Drop the effervescent tablet. Yes, it's time for the main event. Once your liquids are perfectly separated, take that tablet, or actually, scratch that. If your cup is kind of small, just use half a tablet and drop it right in. As it falls through the oil and hits the water, just watch what happens. Bam! Brightly colored bubbles detach from the bottom layer and shoot rapidly upward. It is an absolute dynamic show of swirling colors.
Density, the scientific principle explaining why the oil floats on the water without mixing. So what does this all mean? Why exactly is this happening? Well, the science behind the spectacle comes down to density. Water is simply denser than oil. Its molecules are packed more tightly together, so gravity just pulls it straight to the bottom. On top of that, they are what scientists call immiscible, meaning their chemical structures completely prevent them from bonding. So, thanks to density, they stay perfectly separated.
Basic chemical reactions, the production of CO2 gas from the tablet that creates the rising bubbles. You see, density only explains the layers, right? It doesn't explain the movement. That movement is driven by those basic chemical reactions. When the tablet hits the water, it produces carbon dioxide gas. These brand new CO2 bubbles are incredibly light, and as they rush toward the surface to escape, they literally drag little pockets of that colored water up through the oil. Then, when the bubble pops at the very top, releasing the gas, that heavy colored water sinks right back down to the bottom. It's this continuous loop, driven entirely by chemistry.
What color will you choose for your homemade lava lamp? That's the ultimate question we're left with today. Think about it. You've just mastered the concepts of liquid density and chemical gas reactions, all by creating this amazing kinetic art. But before we wrap up this explainer, I want to leave you with one little thought to test out yourself. If temperature changes how fast molecules move, what do you think would happen to the speed of your lava lamp if you used warm water instead of cold? Go ahead, test it out, and never